Dr. D here, and today we're going to learn a little about acids and bases, what they are, what is a conjugate pair, and go over some strong acids and bases and some weak acids and bases. So let's dive into it in Content with Content. So what is an acid or a base? Well, honestly, it depends on which famous old person you like to talk to. In 1984, Savante Arrhenius defined an acid base as when you mix something in water. If it produces H3O+, then it's an acid. If it produces OH-, then it's a base. And about 40 years later, in 1923, Johannes Bronsted and Thomas Lowry decided to broaden this definition a little bit and say that an acid is a proton donor and a base is a proton acceptor. So we don't necessarily need to have that OH- anymore. And then that same year, Gilbert Lewis decided to expand it even further and say that an acid is an electron pair acceptor and a base is an electron pair donor. So now we don't even need to have hydrogens. But irregardless of which definition you like to use for acids and bases, let's take a look at some characteristics about them. So if we have HCl, hydrochloric acid, we can mix that with water and it's going to make a hydronium ion and a chlorine anion. Now, we know that HCl is an acid, but what about this Cl-? Well, that would be considered a conjugate base. So we have HCl as an acid, and we have chlorine- as its conjugate base. It's a base in the sense that it could take on a hydrogen, but it doesn't necessarily have to. All right. So let's take a look at another one. Let's say we have sulfuric acid, H2SO4. That would be our acid, and its conjugate base would be HSO4-. Now, even though this is our conjugate base, let's say we use that as our acid. Let's say we have HSO4- as our acid. It can still lose another proton and become SO4 2-. And let's take a look at some examples of bases. Let's say we have ammonia, NH3. If that reacts with water, it'll form OH- and then a conjugate acid. So it'll form NH4+. If we look at OH-, its conjugate acid would be H2O, or water. So depending on what you're looking at, that's going to define what would be the conjugate pair. Conjugate pair is just the conjugate base or conjugate acid to the respective acid or base. And they differ by only one proton. So all the conjugate pairs only differ by one H+, one proton. So when looking at acid strength, we have what's normally defined as strong acids and weak acids. So for the strong acids, a lot of times this can be characterized as being any hydrohalic acid or a halogen with an H on it, with the exception of HF. And some examples of these would be HCl, HBr, or HI. Some other strong acids would be oxoacids that have two or more oxygens than hydrogens that can be ripped off, or protonated hydrogens. Examples of this would be HNO3, H2SO4, and HClO4, where you notice that we have at least two or more oxygens than the hydrogens. Now for weak acids, we have hydrofluoric acid, and unfortunately this is one you just have to memorize. We also have where we have H+ not bonded to oxygens or halogens. Examples of this would be HCN, H2S. There's actually a good number of compounds that meet this criteria. And then if you have an oxoacid that doesn't have two or more oxygens, then hydrogens you could rip off. So this would be like HClO, HNO2, H3PO4. And then finally we have some carboxylic acids. This is when we have a carbon double bonded with an oxygen that is also bonded with an OH. So we have CH3COOH, and we have C6H5COOH. All right, so this covers our acids, but what about our bases? Well, for a strong base, this is when we have any alkali metals that are bonded with either an oxygen or OH. So this would be such as lithium oxide, sodium hydroxide, or potassium hydroxide, as a couple of examples. And it would be any alkaline metal bonded with either oxygen or OH. And this would be such as barium oxide, calcium hydroxide, or strontium hydroxide. Now for weak bases, it's a little bit more limited. Basically, it's anything that has a nitrogen on it. Now there's a lot of other weak bases, but these are some general rules where they will always be that. So we have ammonia, which is just NH3, and then we also have any amine. So it's basically a nitrogen attached to other things. So it'd be something like CH3, CH2, NH2, CH3, 2, NH, and C3H7, 3N. All right, well, that's all I have for you today. Hopefully you learned a little bit about our acids and bases in this quick introduction. And as always, keep thinking, and I'll see you next time. Goodbye.